So, for example, this is the kind of visualizations that you can do. It's actually the same data that you visualize on the portal, but it's just connecting to the service and doing some heat maps. So that's one example. Or you can create even an iPhone version of the same portal. That's something we developed it as an example of the kind of alternative presentations on the data. So yeah, the iPhone was new, so we all want to try it, and things like that. So, and this is all connecting through the services. So the GBIF is providing a set of services on top of this network of providers, so that it's easy to create these kind of applications, basically. Well, some providers might also provide pictures, like you're seeing here. This is an herbarium, so this is an herbarium seed, a plant that has been put into papers. Okay. But how does it work internally? I mean, how we connect the different providers into the network, get their data, visualize it, etc. It's very influenced. It's actually very based on an organization called Biodiversity Information Standards, or TATWIC. That it's the one that is in charge of creating biodiversity standards. So it's comparable to something like OGC, but specifically for biodiversity. So there you have things like it's right new, is the Darwin Core, something similar to Dublin Core, but specifically for biodiversity. So there you have a lot of terms like scientific name, when it was collected. Well, here I just took 3 of them, like how we define what, this is the scientific name. It's when, is the event date, and where. Where we are actually doing it with latitudes and longitudes, but this Darwin code is going to be also released with GML application schema, so that you will be able to use it. And the good thing about it is, like, if you have any time, if you're going to have to create any service that is related to biodiversity, that's something definitely you should be trying to look at. There's a lot of tools that actually already support this standard, so you get a lot of them. So that's how we work at it. And yeah, and that's have given us 170 million records of open data. So for me, it's quite impressive that we've managed to mobilize so much data, and that it's freely available for everybody to consume. So, okay, the second part of this talk, I wanted to talk more about how we're making use of this data. So the different projects that it's, once you get all this information, what kind of things we can do with it. So first one we're going to be talking is about a project that we developed together with GBIF and World Conservation and Monitoring Center, the UNEP World Conservation and Monitoring Center. So that it was intersecting the data in the GBIF network, these 175 millions, with the world database on protected areas. That is something like 150,000 protected areas around the world. So I'm doing a video because I didn't trust on the connection. Okay, so that's how we work. Okay, so the way we're going to view it is first through a project that's called IABIN. So this is handling the protected areas only for America. And in this portal, what you can do is explore these protected areas. It's been developed by this WCMC. You can see things like like the number of protected areas in a per country, the size of the protected areas. Protected areas can be filtered depending on the kind of protected areas they are. I mean, the IUCN is creating a list of classifying the protected areas. So that's kind of things you can do with filters. So I think in the video I was trying to zoom close to Banff in Canada, because this is where I'm going on holidays after the conference. So it's always nice to to see what is going on. And so let's see what's okay. So I click now in Canada. So there's around 5,600 protected areas in Canada, and this means around 8% of the land being covered. So there's a lot of protected areas around this area. So this is Banff already. So we visualize it together. On this application, we really try to make use of other existing services like Wikipedias and panorama pictures and so on, for you to get an idea how it is. So the interesting thing about biodiversity comes on the area details. So the map that you see on this little map is actually representing the data that is available on the GBIF network for this specific area. And if we click on it, we get to another application that was also developed together with GBIF and WCMC, where you actually gonna see the real records. So that's again this is BAMF. Showing it again the different things. So here it says like there's 6,000 occurrences, so primary records of primary data as described on the GBIF network. Out of these 6,000, 5,000 are animals, 550 is plants and things like that. So we're already connecting these two databases. So I think the loading takes some time on this one. But yeah, so this is the list of the species that can be found on this protected area based on the data from all these different providers. You can also visualize it as a tree because by scientific names it has a taxonomy. So we're trying to get pictures automatically from the web because there's not many repositories of pictures available out there. So sometimes it doesn't work very well. Yeah, so here you can see it also on the top. It's very little. It's not, probably you cannot read it, but it's saying something like out of these 5,500 records that we have on GBIF, 4,000 are observations. So that's someone that went there and make it an observation. Say, I found this, but I didn't take it. A specimen is when they actually take it and put it in a museum, and that's important because that helps the researchers to give a level of confidence. So if it's a specimen, someone can actually go to the provider, could go to the museum and say, well, it's here, okay, yeah, then I trust on it. So other things you can do is, okay, so you can visualize the pictures. That was part of the demo. So you can see the data sources. Again, the data is aggregated from all these sources. So here you have the Academy of Natural Science, Arizona, and Avian Knowledge Network. So these are all the providers within GBIF that are providing data for this particular protected area. And of course, you can also download the data in multiple formats like KML, CSV, and things like that. So I think that's all for this project. So how this worked a little bit more in detail, it was this intersecting. At the time when we developed it, the first time it was 160 million, now it's 175 million. So it's increasing the numbers in GBIF every month. But at this time we were intersecting these 160 millions with this 150,000 polygons. And that became starting to become a problem, and scalability in biodiversity is a big problem. So this process of finding what species are within what protected areas took around, on the last, after heavy optimizations, it was something like 16 hours with a relational database like PostGIS. So that was running on our computer, 8 cores using it, querying at the same time the database, and it was still something like 16 hours. The new versions of PostGIS probably are faster, but that was we get then. At the same time we were doing it with a relational model, the more we are starting to do this analysis, we are realizing that it doesn't scale. So if the data within the GBIF network starts growing as it's supposedly going to be growing, we might have something like 1,000 million records within 1 or 2 years. So that's not going to be working very well on the relational model. So we started taking a look on reproducing these spatial joins that we did with PostGIS, but using MapReduce, using Hadoop. This work was done by Tim Robertson, that works for Global Biodiversity Information Facility, and it's actually available. The results we managed, I think, to do the same work in 4 hours with something like, I think it was 10 machines. So the cool thing about it is 4 hours, 10 machines. It could be that we make it in 2 hours with 20 machines. So it's scalable. It can scale. So if you want to check it out, it's on the blog.